Okay. Part A. One should be straightforward. Just write down C. It's given by this chi 1 to 3, 1 to 5. Right. So yeah, 1 is 3, 2 is 2i, 3 is -1, 4 is 0, 5 is 1. Right. Okay. Then the U I use is the one in the textbook with changing all the I to -I. Right. So C pi T is C pi is U times C. The U is what I use, -1 over square root of 2 I square root of 2 0 0 1 over square root of 2. Again, I over square root of 2 0 0 0 0 1 is I square root of 2 1 over square root of 2 0. Zero, 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 zero. Wait, hopefully I calculate 3, 2i. Wait. Have to keep doing it. So this the first element is just this times that. But only have two terms. This times this. -3 divided by square root of 2. And then your item i's is -1. So -1 -2 divided by square root of 2. So 5, right? -5. Right? Yeah. Second one is pretty much the same, except that the 3 now it says -3 -2 is 1. And the third one is just one term because this time that is here, this time that is here. Square 2. And likewise, this one is -I. Yeah. The last one is trivial. Right. Let's see if I got it.
Yeah.
This is right.
Oh.
-5. Oh, you saw it? Okay.
With
Okay.
I was comparing it to the wrong B.
Well,
it
let's just do it explicitly. 3. C is one to show Ci. This is Ci pi, just sum over Ci pi chi I pi. Ci pi and chi pi in whether this is the same as the original one. Well, Ci pi and chi I pi is you need to look up those chi. Where are those chi? I think it's an example, right? The chi pi so basically this one is this one multiplied by the chi. Yeah, chi So we have it seems like a lot of terms. So minus 5, I have 5 square of 2, and chi1 pi is minus 15 over 8 pi. The minus become plus sine theta cosine theta e to the I phi. I theta, I phi. Right. And then C sub 2, chi sub 2 is 1 square of 2, 15 over 8 pi, sine theta cosine theta e to the minus I phi. Okay. I sub C is C3 I over square of 2, and chi3 pi sine square theta e to the 2 I phi. Okay, and then minus I over square of 2 chi 4 pi 15. My phi is not very good. 32 pi square theta e to the minus 2 I phi. And then lastly is chi phi, which is chi phi pi is the same as chi phi, which is 16. Because it's square theta minus 5. All right, you want this to show whether this is equals to Ci chi I, right? And this is let me see if I did it correctly. Here, 5 plus I plus 1, yeah, and then I, right, yeah, both have the same chi, so chi phi doesn't matter. So it's 3, whether it's equals to 3 or 15 over 4 pi sine theta cosine phi plus 2I square 15 4 pi theta cosine theta sine phi. I3 is minus 15 theta sine phi sine phi. And then chi phi, which is the same. So this is the same as this one. This is chi phi. It's the same. Okay. So you just need to compare the rest. Okay. Hopefully it will turn out to be correct. Right? Why? What?
I forgot it was 0.
It was 0. Yeah, 4 1 4 for the 0. Yeah. Okay. Yeah. Let's see. Compare the first is this one and that one combined to. I mean, this one seems like it's easier. That's it has sine theta, cosine theta here, sine theta, cosine theta, sine theta, cosine theta. So these two terms should be compared with these two terms. And these two terms should compare with this one. It seems like this one is easier because they have the same coefficient, right? Everything the same except that you have 2I phi minus e to the minus to I phi. Let's work out, let's check this 2 with this term, right? So that one is the other than the common coefficient. Square theta. The rest is this minus that, which will get rid of the cosine to phi. And so you have sine 2i times sine 2i phi. 2 phi, not 2i phi, 2 phi. Right? This one minus that one, right? And then you have I times I is minus 1, sine 2 phi is 2 sine phi cosine phi, right? And now you just work out the coefficient I times I is minus 1 minus, you have 2, and then another 2, so it's 4. 4, just write out explicitly, because that's all in the square root here. The 4 go into the square root, becomes 16. And then 2, 32 pi, right? And 16 divided by that is 2, right? 2 times 4. So altogether is 4. 15 over 4 pi. We get rid of all the, minus I. I and I cancel only. You don't have an I and I become minus 1. Minus 15 over 4 pi sine square theta sine phi cosine phi. So this work out, right? So your problem is not these two terms, right? This two terms is okay, right?
I was having a sign issue with that term. That seems to solve it. I was also
So now,
or the chi.
yeah, it's these two terms. This now is the rest is compare this two terms with these two terms, right? It looks like we have some trouble with the I here, right? You have cosine phi. This one only have cosine phi. This one has sine phi. And this is E I phi. This is equal cosine E minus I phi. So both have a cosine phi. So why don't we just compare the cosine phi from this two and compare with this one, right? The cosine phi term is the cosine phi. You have the common one is 15 over, well, we have square of 2, those are common also. 8 pi sine theta cosine theta and cosine phi. Consider cosine term. And the rest is just phi. Right, this is phi. This is 1, 5 plus 1 is 6, right? Your phi, this is 1, 6. Yeah, let's see if the coefficient is right or not. Now pull this inside 16. It's always. And this is 3. You have a 3, right? So the 3 here and get the 2 inside becomes 4. 4 divided by this 6, 4 pi. 4 pi, 15, 3. Sine phi, cosine phi. Sine theta, cosine theta, cosine phi. Wait, that one is correct. Right? And it's so far, one last one. Okay. Let's see, you get the same problem. Sine phi. Now the same thing, do the same thing or the common thing out. Square 2, 15, 8 pi, sine theta, cosine theta, sine phi now. Right? And now there's an I for here, 5i, and this is -1. 5i minus I is 4i. Okay, let's see. You have 2i. Do the same trick here. 2. Just get rid of 1, 2, and then 2 inside is 4. Just get inside becomes 2 divided by 4 divided by 8 divided by 4 is 2. 2 times 2 is 4. 4. 15, 4 pi, 2 I, tan theta of cosine theta sine phi. Right? I got it. Yeah. Because e to the I phi is cosine phi plus I sine phi, right? This is cosine phi minus I sine phi, right? So just compare the first. This one is take the cosine term of both, and add the cosine term because that has all the dependency. That's this term. So the rest is just compare the coefficient whether I got it correctly. And likewise, the other term is just add a sine term. The only difference between this is 1 and 1 plus 1. This is I minus, multiplied by the coefficient. Right? Right? I seem to get it right. Well, which part do you think you kind of getting a typo or something?
I think the issue that was happening is instead of using the chi's in the example, we just what we use, we assume them from the matrix. How does one explain words? What we did.
We try to find chi1 prime in terms of chi1 using the unitary matrix.
Oh, okay. That could be troubling because that you need to use the inverse because they multiply together. You see this is invariant. This equals to that, right? If you transform pi using this transformation, then the other one transform different. You transform using the inverse, or for unitary is just dagger, right? U and U dagger, because likewise you can say that's why like here this is C pi, Ci. This one Ci pi. If you define it as U Ci, right? But then I want Xi pi Ci pi equals to Xi Ci, right? And then this equals to Xi pi Xi, yeah, that's right. And substitute this into here, UCI, right? In order that you transform X becomes different here, you want to transform X pi as the X pi will be like Xi U inverse, right? That one, you substitute this into that, and now that becomes Xi U inverse U C. Right. So it's different. I mean, I'm not using strict more rigorous index notation. You suppose in this is index. Okay, I mean, just treat it like vector statement. Okay. So maybe you did it differently, but if you use the chi or chi pi in your textbook, that would be fine. So the typo is in U. The textbook has the just the, I don't know how he did that, but got the complex conjugate of U instead of U. But the chi are correct. The chi and chi pi are correct in your textbook, but not the U. And okay, this one.